Alright, real quick, just want to show I made up all of the SMC-12 cards here, and the instructions are very good. I went through and followed how to make it, but at the end they don't really tell you how to test it. It just says cleanup and inspections. Okay, well, I'd rather test it before I actually go out there and install the thing in the layout. So this is what I did. It seems to work okay. Just wanted to pass it on for folks that come along because it doesn't really tell you to. So start off, here's a voltage, again my power supply. Right now it's set at about, let's see here, about 11, just over 11 volts. It's adjustable, but that's fine. Again, I just want to see if the thing does what it's supposed to. So when you have the input line, this line here will go back to the S-Mini, and it's going to either be open circuited or grounded. And when you do that, you'll see right now, for example, the A1 and B1 go out to a tortoise. Pins 1 and pin 8, and the same for all across the top there. So right now, pin A1, you can see is low, 0. And this one is at 9.7, 9.8. So now if I take the input and I ground it, which the software would do through the S-Mini, you can see that's going to drop down to 0 on the B1, and the other one is gone up to 9.8. So that would throw the switch machine. So I did that for all of them, for all the different lines. And just to give you a gee whiz thing here, so I hooked up one of my spare tortoises to this particular one. And again, so the line's open, so the tortoise is in that position. It could be normal, it could be reverse, whatever. But now I'll take the input line and I'll ground it. So that basically flips the polarity on those two, and then there it is. So then if the computer says, open that please, and then boom, that opens the line and it throws the switch. So just wanted to show that because I wanted to make sure that, you know, obviously the boards are okay prior to installation, and they do look okay. And on this particular one, what I decided to do, this is the one that I had cut, and I did the same thing. I tested it with the voltmeter, not with the tortoise. But what I did on the back of this one here is I just soldered wires onto the buses there. That left a lot there and just made a nice solder connection. And then I'll run this down, I'll mount it on some standoffs and down to a terminal board, since we don't have the screw terminals that we have on this one. So that's it real quick. I just wanted to show how you can go ahead and test the SMC-12 card. And I also made up, that's the other SMC-12 card, but I did finish this morning. This is the RS-485 card. Just got that done. I don't know how to test this one. It doesn't really give me any way at all to test it, other than, you know, when the computer is sending data. I think this one flashes when it's data is going the other way. Yeah, see the arrows there. This one flashes, but I don't have the computer hooked up to it yet, so I don't know that I can really test it. But it is done. So this one I'm kind of going on faith. But again, like we showed before, you can test the DCCODs to make sure they're okay. That's how you can test the SMC-12s, and there are some things you can do for the S-Mini that I'll get to later. But again, I bought those pre-installed, so I'm pretty confident that they were tested prior to shipping. So just wanted to show that. So thanks for watching, and more to come later. Alright, a little quick control update here. We're starting to do some of the controls. Another thing we did today, we went through and put all the LEDs in. Steve did, and he tested them all to verify before we do any connections that they're all good. And to test them, we use this handy dandy little, it's actually called a signal tester from Logic Rail Technologies, which is kind of neat. So he used that to test the LEDs and make sure they're all good, which they all are. So now, the particular circuit we're using here is with a switch. When it's down, it'll be in motor or in computer control. The CMRI will control it. These will just eliminate, you know, if you're normal or reverse, that's all. Now, when I flip it to hand normal, this LED comes on. It says machine in hand. Again, this is not the perfect way, the most prototypical way, but it's the way we're going to do it. And then if I go hand reverse, I'll throw it reverse. So that way we can throw these basically without the computer being on. These other switches are just going to be straight, pure, normal 2 LED with a reverse wired double pole, double throw switch, typical for a tortoise. No computer interface because these are totally off the main line, so they'll always be good to go. And I see, oh, we forgot an LED. Look at that. I'll have to go back. I'll have to give Steve a demerit for that. But these switches here can either be in dispatcher, computer control when they're on motor, or flip them to hand normal, and then they come out, basically come out of dispatcher control, so to speak, and they go in hand. These probably in real world I think would be locked, or mechanical locks or something like that. But anyway, that's the way we're going to do it, so we can run trains without the computer being here and still throw switches. So the question then comes up, all right, that's great, but now how do I actually do this circuit? Let's go over to the workshop and I'll show you kind of what we came up with for that. Alright, so here's the circuit. Again, this is right out of the handbook from Mr. Chubb and the CMRI stuff. I didn't make this up. This is the one we're using. It's figure 712. And again, it's not totally prototypical, but it does give you the computer control and then hand normal, hand reverse. Okay, so what this is, here's the SMC-12. Again, that powers the turnouts. And the way that this works is this double pole, double throw, center off switch, when it's down, you can see this is the input line from the S Mini. Down, it goes up, and that controls the turnout. And also when it's down, this little part over here is grounded, and I'll talk about that. So when it's down, this LED is off and the computer controls it. Now when you flip it up to hand normal, you can see what happens is obviously the S Mini input line is no longer connected to it, so there's no computer control. With this being open, then you can see that this circuit over here, which is 5 volts, there are 2.2 k ohm, a 220, and there's a 2N4401 transistor here in this LED. When this comes up, this conducts and the LED goes on, showing that you're in hand. And then it stays that way. Then when you go up to hand reverse, all that does is, again, if you recall the other video we had on the testing the SMC-12s, here that switch is, this input line is open, and then going up to here you can see it grounds it. So that will then reverse the polarity, which will then throw the switch back and forth. Normal, reverse, normal, reverse. And then when you do that, this LED is going to be on. So the question that always comes up, and one of the things that's always one of my pet peeves is, this is great, they show you this, but how do you implement that? How do I physically do that? That's always something that these books never show you. I mean, this is the easy part, the circuit. Okay, I get that. So what I did was thought about it and came up using this here. This is a basically just a simple strip board with vertical strips. The part number, again, I got this from Mauser. So that's the part number 854-ST1. And I bought a bunch of them, and then what I did was I actually cut them in half to double it up. I don't need the whole board, so I just cut them in half with my little saw. Actually, the same saw that I used for my fast track switches. So I have this, and then I laid out basically these components on here, and it probably isn't the easiest to see, but here is actually what I did. And basically I bought this this little terminal block here for the inputs, and that is this part number here, 651-1729160, again also from Mauser. I bought a bunch of those and several extras in case I make a mistake. So basically what I did was, with this, again, to lay this out, I bring the 5 volts in. The 5 volts is going to be up this will be the same. And then through the 2.2 k ohm, to here, and then that will come down and go out to the switch. So that comes down and it'll go out to the switch. So that's basically this line here. 5 volts to the 2.2K will go to the switch. And then it also, you see, it goes through a 220 and then goes out to the LED. So it also, the 5 volts comes in, goes through a 220 and then out to the LED, which on here is the 5 volts through a 220 out through an LED. And then back from the LED. You come back from the LED, the return, the cathode of the LED goes to the collector. So that comes in, goes up, and goes to the collector right here. The emitter is simple. The emitter just goes to ground. So the emitter just comes down. This one here, and it will go to ground. So the emitter comes down, no other connections. This is going to go right to ground. And then the base also comes through this 220 ohm, which is this resistor, to this point over the switch. So basically it just commons all right here. And then this goes out to the switch. And then the switch does this thing. Now, I don't have this yet, but I wanted to test this to make sure it works. To make sure I had their transistor in correctly and whatnot. So here's what I thought I could do. Alright, so what I'm going to do is, here's the LED. And this is the exact one that we're going to use, the one that Steve just put them all in and tested them all. So what I'll do is we're going to go over to the layout, and I'm going to bring the 5 volts in from the power supply, and that's going to do its thing. This is going to be the switch, but what I'm going to do is, since all it really is that the switch, in terms of lighting that LED, is either open or grounded. So when it's open, again, when it's open, that LED will be on, because when this line is open, I'm in hand. When I'm in motor, it's shorted. So I'm going to start off having it basically just not shorted to ground. I'm going to have this connected to ground. This one here is just the ground connection, which is really here, which gets the emitter and takes it to ground. So we're going to go to the layout. We're going to make 5 volts in. I'm going to take this and go to the ground of the power supply. I'm going to start off with this being to ground, which will be like we're in motor, so the LED should be off. And then if I open it, that's simulating flipping the switch up, and that LED should go on. That at least proved to me that this little fancy little breadboard circuit here works, and I can build the other 15 that I need. I'm not going to build 15 of them, 16 of them, until I know it works. So let's go over the layout, and we'll hook it up, and we'll see if it works. Alright, so here we are. So here's the little circuit, the LED, everything popped up so we can get a good look at it. And again, I have the 5 volts coming in from the power supply. The 5 volts comes in. The switch is simulated. This comes out here. Right now it's just this right here, which currently is connected to the ground, which also goes back to the ground of the power supply. And then being grounded like it is, that's the switch down. So when I turn the power supply on, that LED should be off because I'm in dispatcher control or motor control. So we're going to turn it on and see what happens. Okay, power supply is on. Verify that. You can see the LED is on, just to prove it. Okay, now when I take this off, that LED should go on, which simulates flipping that switch up and going into hand. So let's see what happens. Alright, so I don't know how well that shows up on the video, but and again, you almost have to look right at that. But that LED is on, which will be the indication that the switch is in hand. And then if we would, throw that switch back down again, it's going to actually put this back to ground, and the LED goes off. So it looks like the circuit works. So that's promising. So now I can go ahead and make 15 more of these. And then the concept for this was, boom, there it goes. I'll drop my supply power. The reason I wanted something like this was because you got to consider, and I bought these LEDs on purpose with a longer lead, so I'm actually hoping from the control panel I can go right to this without having to solder, just bring it right into this. So, as we showed before, this is the control panel that Steve put all the LEDs in. That LED is this, so the concept will be that will mount this somewhere, hopefully within reach, maybe on the back side here, where we can put that in and not have to solder and just have that the board sitting in the back. Now you do need one for each, so I need 1, 2, 3, for example, for this control panel. So we're going to have to find room in the back for that, but that's the concept. And then really all I have to do is bring in 5 volts and go to ground. And we'll work on that when we get other things. I also have to bring 12 volts in for the switches and whatnot. The SMC-12, that little piece that I made, I'll have to fit in here too. So that's the concept. But just wanted to show again, sometimes going from a drawing in a piece of paper in a book to actual reality, and this is very simple, but and this is not the only way you could do it. I'm sure other folks have done it other ways, but again, when you have these things on a drawing, they can't just float in space. You have to physically do something with them. So that's how we're going to do it. And again, hopefully the LED leads, I bought them on purpose like this, long enough, so we won't have to do any more additional soldering. And obviously the switch will be in here, so hopefully we can make all those connections. So again, just wanted to bring that up and show how we got that done, and we're moving along here. So more to follow. Thanks for watching.